Hey everybody, this is Mr. Ainsworth, and we're going to get started in a review on exponential growth and decay functions. All right, starting off with a decay function with base 1/4. All right, so let's get right into it and see how it's done. Let's see here. There we go. Okay, so we're going to be working on two problems, by the way. Base 1/4, and then the next one, base 3, all right, which is a growth function. So we're going to be reviewing each one at a time. So let's start off with, in the domain here, let's pick some x values here. Let's start off with -3. Okay, so 2 times 1/4 to the -3 power minus 1. Okay, we always reciprocate first. So this is 2 times, all right, 4. The reciprocal 1/4 is 4 raised to the third power minus 1. Now 4 cubed. So let's do powers of 4. Powers of 4. Okay, so starting with 4, 16, 64, 256. Okay, you need to be able to get up to that high right there by multiplying by 4. You can go higher, of course, okay, but this is as high as we need to go mentally, of course. Okay, so 4 cubed, that's 4 to the first, right? 4 squared, 4 cubed, 4 to the fourth. All right, so 4 cubed is 64. So this is equal to 2 times 64 minus 1. That's 128 minus 1, or 127. Not going to be able to plot that. Left 3 up 127 is off the graph, but it's okay, we got it. So that's a point on the graph. It's really steep up there. Okay, so 2 times 1/4 to the -2 power, all right, minus 1. Always reciprocate first from here to here. All right, so it's 2 times the reciprocal of 1/4, which is 4, to the second power minus 1. That's 16. So you evaluate your exponents first. So 2 times 16 minus 1. 32 minus 1 is 31. At -1, we have 2 times 1/4 to the -1 power minus 1. Always reciprocate first. So it's 2 times 4 minus 1. Since 8 minus 1 is 7, we get 7 there. We can plot that. We're going to start plotting here. At 0, 2 times 1/4, all right, to the 0 power minus 1. The 1/4 to the 0 power is 1, so we have 2 times 1 minus 1. 2 minus 1 is 1. Plot that. That's a y-intercept right there. When x is 1, we have 2 times 1/4 to the first power minus 1. All right, which is 2 times 1/4 minus 1. We're going to simplify a little bit. Okay, divide both by 2. We get 1/2 right here, minus 1. So 1/2 minus 1 is -1/2. And then when x is 2, we have 2 times 1/4 to the second power minus 1. 1 squared divided by 4 squared is a 16th. So 2 times 1/16 minus 1. Okay, 2 divided by 2 is 1. 16 divided by 2 is 8. So I get 1/8 here, minus 1. What's that? Well, it's negative, right? And if you take out 1 from 8, you have 7 remaining, so -7/8. All right, when x is 3, we have 2 times 1/4 to the third power minus 1. That's 2 times 1 cubed is 1. 4 cubed, like I said earlier, is 64. So 1/64 minus 1. So you got to divide both by 2 and simplify. So divide both by 2, you get 1/32. So 1/32 minus 1 is -31/32. All right, and we do not need to go any farther, okay? So what I'm going to do is I'm going to start plotting here, okay? Because I can't plot these. Okay, I can't plot this one and I can't plot that one. Okay, because I can't go left 2 up 31 according to the scale. I'd have to change a scale in order to do that. So I'm going to plot these values here. So look in red here. I'm going to go left 1 up 7. So left 1 up 7. 0, 1. There's your y-intercept there. Okay, and then 1, -1/2. So right 1 up, right 1 down 1/2. So right 1 down 1/2. Be accurate when you plot. Right 2 down almost 1. See, negative 7/8 is almost negative 1, so it's down almost 1 unit right here. And then right 3, down almost 1. This approaching right here, these are approaching negative 1. Never get there, but all right, but they're approaching negative 1. So we're going to go right 3, down almost 1. Okay, not negative 1, not exactly down 1. Okay, this will never be negative 1. It approaches negative 1, as you can tell, and that means we have an asymptote. So let's draw your horizontal asymptote here at negative 1. The function approaches this horizontal asymptote, HA for horizontal asymptote, as you guys already know, at y equals negative 1. See, these y values approach negative 1, and that's why the horizontal asymptote is negative 1. All the y values are above it, and they're greater than that, so y, the range, is greater than negative 1. So let's go ahead and draw the function here in blue. It's very steep. And it's a decay function, so it goes down. It's decreasing. It's decaying. All right? And then it flattens out along this horizontal line called an asymptote. All right, so let me see. We have a y-intercept, of course, right there, 0, 1. It doesn't intersect the x-axis, so we don't have an x-intercept. And as I've said in all my lessons, the domain for all exponentials are all reals. Okay? And decay functions have a very special property. As x increases, okay, goes up, y decreases, goes down. Okay, it's an inverse relationship here. And that's a fact for all decay functions or decreasing functions. As x increases, y decreases. It goes down, and that's why it's sloped downward as opposed to upward in the growth functions. Okay, speaking of growth functions, let's go ahead and take a look at one. So here now the base is 1/3. Excuse me, the base is 3, which means it's a growth function. Whenever the base is bigger than 1, we have a growth function. So growth, okay, implies that we have a base greater than 1. Okay, obviously 3 is bigger than 1, so it's going to be a growth function. It's going to curve upward instead of downward. All right, so let's start off with the domain here at negative 3. Let's take 1/3 times 3 to the negative 3 power minus 4. And this is going to be 1/3 times 1 over 3 cubed, or 1/27. So you have to evaluate your exponents first. All right, and when you multiply your fractions here, you get 1/81. Powers of 3. Let's do powers of 3 over here. Powers of 3. Okay, 3, 9, 27, 81. Okay, 3 times 27 is 81. So you guys already know that. So 1/81 minus 4 is negative 3 and 81. Okay. Okay. Let me just think about something here. Okay, continuing here, we have x equals negative 2. So 1/3 times 3 to the negative 2 power minus 4. You evaluate your exponents first, so you get 1/3 times 1 over 3 cubed, or 1/9. All right, minus 4. This right here gives you 1/27 minus 4, which is negative 3 and 26/27. When x is negative 1, we have 1/3 times 3 to the negative 1 power minus 4. 1/3 times, all right, 1/3 minus 4 is 1/9 minus 4, which is negative 3 and 8/9. When x is 0, you have 1/3 times 3 to the 0 power minus 4. That's 1/3 times 1 minus 4, which is just 1/3 minus 4, or negative 3 and 2/3. And when x is 1, we have 1/3 times 3 to the first power minus 4, which is just 1/3 times 3 minus 4. These 3 divided by 3 is 1. 1 minus 4 is negative 3. When x is 2, we have 1/3 times 3 squared minus 4. So 1/3 times 9 minus 4. Let's simplify. 3 and 1/3 of 9 is 3. 3 minus 4 is -1. So you have -1 here. 3. When x is 3, we have 1/3 times 3 cubed minus 4. And so we have 1/3 times 27 minus 4. Divide, you get 9. Minus 4, you get 5. Okay, and let's do one more, 4. So 1/3 times 3 to the 4th minus 4 is 1/3 times 81 minus 4. 3 and 81 divided by 3, just go backwards, you get 27. All right, 27 minus 4 is 23. Okay, so I think we have enough points here, and we can plot a lot of them, okay? So what we're going to do is go left 3, down almost 4, because this is, this is almost -4 here. So left 3, down almost 4. 1, 2, 3 to the left. Let me change the viewing here. There we go. So left 3, almost down 4. So 1, 2, 3, right about there. Left 2, almost down 4. So 1, 2 to the left, almost down 4. Left 1, almost down 4 again. 0, -3 2/3. So 1, 2, 3, and then split this up into thirds. There's -3 and this right here is 0, -3 2/3. That's your y-intercept. 1, -3. 2, -1. 4, 3, -5. Whoa, that's not right. That's positive. So 3, 5. Just fix this. 4 minus 4 is +5, so it's equal to +5. So write 3 at 5. So write 3 at 5 right about here. There we go. Now it looks right. Okay. So these if we plotted more points at -4, -5, we would really, these points, we'd see these getting close to -4, but they don't. They approach -4, but they never get there. So we have a horizontal asymptote at -4. Okay, let's sketch the function. It's a growth function. It takes off upward, right? It's as x increases, y really increases fast. Okay, so it goes upward. It's a growth function. Okay, as x increases, y increases. So then now we can answer all these questions here. So we know y is equal to -4 for a horizontal asymptote. Domain, all reals. Range, all these y values are greater than -4. Let me see, we have an x-intercept right here that we can estimate. Here's our x-intercept. It's like 2 1/4 maybe, so estimate. So 2 and maybe 1/4, 0. This is approximate. Okay, we have a y-intercept right here. That's pretty obvious. We just talked about that. That's 0, -3 2/3. Okay, and then this is a growth function. So growth functions have a particular quality. Okay, as x increases. Okay, that means goes up. Y decreases. Excuse me, y increases. Y increases as well. So you'll see that. Look at this. From the negatives to -3, -1, and the 5, 23. I mean, these are getting bigger, right? Y values are increasing. Y values are increasing. It's pretty obvious. They're getting bigger. From 5 to 23, they're getting bigger. So y increases too. They increase together, guys, okay? They both increase. That's an aspect of growth functions. All right, and that right there is a full review, all right, of 2 harder examples, but it's a good review of all the arithmetic and what it means to be a decay function. Let's review that again. As x increases, y values decrease. They go down, and that's why it's sloped downward from left to right. And then growth functions, they slope upward from left to right because they both increase together. Okay, so do your best and review. And I'll see you in my next lesson. Okay, this is Mr. Ainsworth. I'm out of here. All right, make yourself proud. Study.